Hi, welcome to my channel Cloud with Girish. I am Girish, an AWS Community Builder, Cloud Tech Enthusiast with expertise in delivering customer-focused and business-impacting cloud transformation programs of high complexity. In my previous video, I explained how I created a CRUD API using Kiro vibe coding feature. In this video, I will demonstrate how I added a functional UI with Kiro simply by providing prompt without writing any code myself. Kiro generated the UI code, integrated it with the existing CRUD APIs, and even provided clear instruction on how to run the application. With the addition of the UI, the project has evolved into a full-stack application. It now includes a user interface for viewing, adding, updating, and deleting customer information, multiple API endpoints, and a DynamoDB table for data storage. The entire stack is built using an infrastructure as code approach with AWS SAM. Unlike traditional IDEs, vibe coding in Kiro let you code in flow with lightweight prompts. No need to over-specify requirements upfront. It's perfect for experimenting, prototyping, and just vibing with the code. Instead of manually writing services together, I simply gave Kiro a natural language prompt, and within minutes, I had a working deployable prototype. That's the magic of vibe coding. Let's look at what did I build and why. I wanted to create a quick customer lookup full stack application to demonstrate how fast you can go from an idea to a working solution using Kiro vibe coding feature. Instead of manually setting up AWS resources, I described my requirements in plain English, and Kiro generated the entire project for me, including the backend APIs and the UI. Here is what I ended up with. A REST API hosted on API Gateway, and this API supports CRUD operations, so it has the get, post, put, delete methods. A Lambda function for handling API requests. Also a DynamoDB table to store the customer data, which include customer ID, name, state, and zip code. A UI hosted on EC2 integrated with these API endpoints for CRUD operation. An AWS SAM template for building and deploying the stack, and a sample JSON event for testing the API. The goal was not to build a production-ready API right away, but to get a working prototype fast, something I can extend later with authentication, observability, monitoring, and performance tuning. Before diving in, let's review the architecture diagram to understand the flow and how these components interact. So, from my prior video, you would recall that I built the solution which has the CRUD API. So I had a Lambda function which is supporting the business functions to support the CRUD operation. I have the DynamoDB that is storing the customer information, and then there are REST API endpoints integrated with Lambda function using the API gateway. Now with the Kiro, I extended it. So now I have like a EC2 instance, which is hosting a UI, which is also developed in the Python. So now I have a full stack. So user can access the UI, and then through the UI, user can add a customer, view the customer, update the customer, or delete the customer data. So that's really what this architecture diagram is. Showing the flow of different component and AWS services and how they are integrated together to build this solution. Let's look at few of the prerequisites. So basic prerequisites are like familiarity with the AWS management console, knowledge of Python Boto 3, basic understanding of AWS SAM, a very basic understanding of Lambda and API gateway, some basic understanding of event-driven design and architecture, You need to have Kiro installed and ready to go. And of course, you need CLI and SAM CLI to build the solution, and the Python 3.x. Again, because I'm using this Gen AI wonder of generating the code using Kiro, I mean, yes, I should know the code, but in this particular example, I did not write it. It's Kiro generated. Of course, I should have the understanding, like I should be able to walk through the code, understand what it's doing, and so on. But in reality, I didn't have to write the code. It got generated using the Gen AI aspects of with the help of Kiro. So let's review these steps from prompt to prototype. And again, I'm calling it prompt to prototype and not production, because like I said, before you take any solution to production, especially the solution that is generated by Gen AI, you need to make sure that you have reviewed the code, you have performance tune it, you have looked for all the exception handling, the errors, the logging, the monitoring, and so on, right? So there is work to be done. But this is a great example where you can actually have a working prototype rather than having some screenshot built over the period of weeks or sometime months that takes, right? So here you have a working prototype to demonstrate, and then that prototype then can be extended to a full scale solution, right? So here, to going from prompt to prototype, I'm going to start a vibe coding session in Kiro. So for that, you simply open the Kiro and switch to vibe coding mode because Kiro supports vibe coding and specs-driven development. So I'm using the vibe coding, and I'm simply typing a natural language prompt. So I'm just saying, hey, build a customer lookup API as REST API, and API will be hosted using AWS Gateway integrated with a Lambda function. Data will be stored in a DynamoDB table, and then I'm asking that create a simple table to store this data with 4 fields: cust ID, name, state, zip code. Do not create test framework, as I need to get a quick working prototype first before adding testing and performance framework. I would also like to use AWS SAM to build and deploy this solution. So it's a very clear prompt demonstrating that what I want Kiro to do. Prompt engineering, as you all know, is an essential part of working with Gen AI. So if your prompt is clear, then you will get the more expected output from the Gen AI solution. So that's what I'm trying to do with this prompt. Now, with the help of this prompt, Kiro responded to me with the below answer. So this is basically from a Kiro IDE, right? A screenshot. So Kiro is saying that, okay, I will help you build a customer lookup REST API using AWS SAM with API Gateway, Lambda, DynamoDB. Let me create a minimal working prototype. So this is great because it's like the feedback loop. Kiro is working as my teammate and providing me that feedback that, okay, I got your instruction and this is what I will help you build. And then it went ahead and created a template.yaml file. It created a handler, which is the Lambda function. It also created requirement txt, and then it's created a really good README file. So if you are familiar with the SAM framework, then you would know that template.yaml is where all the resources are defined, and SAM is built on top of CloudFormation. It's just a simplified version. So in behind, when you run the SAM template, then it will build the CloudFormation stack for you, which basically will have all the resources for my Lambda function, the API, the DynamoDB, and so on, right? So that's what template.yaml is doing. And then customer handler here, which is really the Python code for the Lambda function. And then requirement.txt, that's basically document the dependency required for Python, and then README, just a README file, right, talking about the solution. So with that, in seconds, Kiro started to produce the SAM template, the Lambda function, the DynamoDB, and the sample JSON. It's also actually created a JSON event. So that's really interesting, because then I can just take that event and use it to test the API with like Postman or Bruno or curl, however way I want to test it, right? So there is a JSON event generated too to test the API with. Let's look at the SAM template. So this is the template it generated. It's not like the full template. I'm showing the partial view here. It created like all the resources, but as you can see, it's pretty standard like SAM template. It did a great job of defining it. It's saying, hey, you have a customer API, and then here is the resource path, and here is the method get, and then it also has like other like create customer and get customer and update customer and so on, right? And then here is a view of the DynamoDB table that it created. It's creating a simple table, and it's basically like defining those attribute here. Billing mode, it took like paper request, which is great because that's what I wanted, and it already like took care of it. And there are other configuration also there about memory size, the permission policy, and so on, right? So really good working SAM template file. I didn't have to change it, just use it as it is. And here is, and then in here is the Lambda function. This is the Python code. Again, this is a partial code. It generated a lot more, but basically if you see here, right, it's a Lambda handler. It's looking for the event. It's looking for the path. And then based on that information, is basically creating a decision loop to say that, okay, it's a get request or a post request or a put request or a delete request, and based on that, it's going to route it to the appropriate function module within that Lambda, right? So again, an example here is that here is the get customer, and then it will retrieve the customer and it will return that customer in the response. So that's really what the Lambda function is doing. And here is the JSON events, right? So here is a simple JSON event that it created for a get request. So here I can say, hey, here is my customer 001, give me all the data back for this customer. So I can test my API endpoint using this JSON event. Now that I have the template, SAM template, I have the Python code, I have the dependency, and I already have my environment pre-configured for SAM. So I'm ready to execute the SAM build command. So if you see here, I simply just said like SAM build, and it started to build the solution. Once build is successful, I can deploy it using the SAM deploy command, which is basically as simple as saying SAM deploy and confirm my parameters. I can change it if I want to deploy it in a different region. So it will give me all those options. So this is really a concise workflow that shows that how to create, validate, deploy Lambda function using AWS SAM. By leveraging AWS SAM, you can streamline the development process and ensure your functions are tested thoroughly. Now, I have a lot of videos on like AWS SAM and Lambda because that's sort of like my favorite setup to try my, prototypes, the ideas. So on my channel, you will find many different examples where I'm using the Lambda and I'm using AWS SAM framework to build and deploy those Lambda and the API. I use them for, the traditional CRUD operation supported API. I also use Lambda to integrate with Bedrock and the Gen AI, the LLM sort of thing. So you will see all of those on my channel. So I encourage you to watch those videos and I will continue to build these solutions. Now, when I use SAM deploy, before it actually deploy it in my AWS cloud account, it's going to create the change set and it's going to ask me for the confirmation. So once I say yes, go ahead and deploy it, it's going to go ahead and deploy the change set in my AWS account. So here in this example, SAM packaged and deployed the API gateway, the Lambda and DynamoDB, which is needed for my backend API build-up support. Now, since these resources have been deployed in my AWS account, I logged into my AWS Management Console to verify them. So here is what I checked. I checked that API gateway REST API is there with all the CRUD endpoint for get, post, put, delete. I looked at the Lambda function, validated that function was created and linked to API gateway. I looked at the DynamoDB table. It of course has no data. It just created a table with those fields that I specified. And then I just looked at the CloudFormation SAM stack. Now, this is all the view part. I did not change any of these. It's basically as it is. I deploy it and just I wanted to look at that. Yeah, all of these things are actually get deployed and exist in my account under the right region. So that's what I did. And this is the screenshot where it's saying, hey, here is your table, here is your resources, and so on, right? Now, since I have it now in my account, that gives me the next logical step, which is to validate the API endpoint. So I'm going to use the Postman to invoke the API, and I will review the response return. However, before I invoke a GET request, I thought let's use a command line to post a record via API that will be stored in the DynamoDB customer table, because table was created empty, right? It has no record. So I wanted to add at least one record quickly, so that when I invoke a GET endpoint, then at least I get the record back, right? So here I'm using a curl command to just put a sample record here with the cust ID 001, Girish and New York and 1001. And then basically you will see that endpoint got, like, I use the endpoint, of course, but that post request added a record in the DynamoDB table. And then you will see that I can actually invoke a GET, and this time I'm using Postman. So I'm putting the endpoint for the GET, and as you can see, I'm getting that record back. So this is a successful response written by the API endpoint. And since this is a CRUD API, it supports other operation as well. So I just use the post and GET request, but basically it can support, like it supports update or deleting the record also through the other endpoint. Now, I have my API, I have my Lambda function, I have my DynamoDB table. So I decided that, hey, rather than using Postman, why not just create a functional UI? Now, rather than creating that UI myself, I thought let's ask Kiro as my teammate to create that for me. So here in this scenario, I simply ask Kiro to create a UI integrated with the API point, and it created those. I will show you in the next screen, but before that I wanted to call out that I did manually added API security feature, so that if a valid subscription key is not passed to API gateway, an error is shown. So if there is an invalid key or no key, then access is denied. If there is a valid key, then response is returned successfully. So I wanted to do it just to demonstrate the practical implementation, because when you have the API and when you are basically integrating it with a UI, with a client application, then you want to make sure that your endpoints are secure, right? And only the client that has access to those API key or other security method can access to the API endpoint, while it is blocked for all others, right? So that's really what I'm trying to do here. So here, if you see, in the first example here, it's saying, hey, invalid API key. So it's not giving me, like, this is the UI that it generated, but like when I try to see the customer information, I'm getting this message that invalid API, because I did not like add the API key yet, but then I added the API key, and this is how it looks when API key is added and passed when invoking the API endpoint. So here now it's giving me the record back, basically. So this is a UI, very simple, great for the prototype, right? So I can, like, from this drop down see view customer, add customer, update customer, delete customer, and then can, like, it's tied to the appropriate API endpoint and to provide me that function. Now, that was a drop down that it originally created, but after validating that, hey, the UI is working, the API is working, the functions are working as expected, I thought let's ask Kiro to update the UI by replacing the CRUD function drop down with radio button. So it's very explicit that these are the 4 functions that this UI is supporting working with the backend. So Kiro actually updated it real quick, and now I have the radio button instead of drop down, and I can simply just click whichever function I want, and then it basically refreshes the view for me. So if I say get, then as you can see I'm getting a get view, but if I say add customer, then it switched to a UI that basically gives me an ability to add another customer. So it's pretty cool actually. Now multiple API endpoints plus a working UI and testing it, validating it under 30 minutes, all powered by Gen AI and Kiro. But does that mean my expertise not required? Not at all, right? Because I'm still needed to validate the solution. I deployed it using SAM. I reviewed it, that solution is deployed correctly, and then I did do the manual step of adding the security with subscription key, quota, and client application invocations. And I did take the steps to deploy the UI app on the EC2 instance. So, but it felt like a team effort where Kiro acted as a peer, helping me generate, review, and collaborate to get the prototype built quickly, right? So that's the beauty of it, right? It's basically working in partnership, in collaboration with you based on your instructions, right? So you basically controlling the output based on your prompts, and that's really the cool part of it that I really enjoyed, working with Kiro. Now that was the working prototype, prompt to prototype. Now when we are done, to avoid charges, don't forget to clean up. Since these resources were built and deployed using AWS SAM, it's really simple to delete the entire stack, just saying SAM delete. SAM delete command gonna ask you a few confirmation, and once you say yes, I do wanna delete it, then everything will be deleted successfully and you have nothing to worry about, right? You don't have to go in your account for each service and delete it. It has deleted the entire stack. So in this video, I demonstrated how Kiro can accelerate the development by enabling the creation of a fully functional CRUD customer lookup REST API with DynamoDB, and then extending it into a complete full stack application with a working UI, all in a fraction of the usual time. While it may not be production ready, it effectively serves the purpose of creating a quick, reviewable prototype for business and technical stakeholders. Kiro not only generated the backend API and application code, but also produced an AWS SAM template and a front-end UI prototype, completing the full stack build seamlessly. Generative AI is transforming the way code is built, and tools like Kiro make the process even easier. While debugging can become more challenging as more code is generated with Gen AI, Kiro features such as spec-driven development and design documentation generation can help address the challenges. I believe this is just the beginning, and these tools will continue to evolve rapidly. I'm constantly creating new content on various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue producing valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.